Hello friends, today we are going to discuss about the introduction of Fourier series, which is our unit number 4. This Fourier series is useful only for periodic functions. For non-periodic function, we have Fourier transform. And the applications of this Fourier series is whenever we have function in the form of whenever we have periodic function, then to analyze such periodic functions, we want help of Fourier series, that is in ECG or many in signals and systems. We need this Fourier series concept. So a function, or sometimes we want to cut some noise in modulation and demodulation system. So at that time this Fourier series is very useful. So first we need to understand what is a periodic function. A periodic function f of x is called periodic if for every value of x there exists some positive number t such that f of x plus nt is equal to f of x for n is equal to 1, 2, 3 and so on. And this t is known as a time period. So if t is a period of f of x, then if we put n is equal to 2, 2t we will get, then 3, 3t, 4t, 5t. So all these are called as a period of a given function. Now, smallest period is called as fundamental period. So if we put smallest value, that is n is equal to 1 here. So n is equal to 1 means only t we are getting. So t is called as a smallest period, which is also called as primitive period or fundamental period of a function f of x. So there are so many periodic functions. For example, sin x is periodic with period 2 pi. Why? Because if we replace this x by x plus 2 pi, then we are getting same function, because sine of x plus 2 pi is equal to sin x. So therefore the sin x is periodic with period 2 pi. Similarly for cos x, cos of x plus 2 pi is also cos x. Therefore cos x is periodic with period 2 pi. Similarly for sec x and cosec x, both are periodic with respect to period 2 pi. Now for the function tan x and cot x, tan of x plus pi is tan x and cot of x plus pi is cot x. Therefore tan x and cot x are the function periodic with period pi. Then constant function has no primitive period. Then if f of x is a periodic function of period t, then f of ax, that is for a is not equal to 0, is a periodic function of fundamental period t by a. For example, if we have sine 2x function, then for sine 2x it is x multiplied by 2. So period of that sine function is now 2 pi. Sin x is periodic with period 2 pi. So 2 pi by 2, which is pi. So sin 2x is periodic with period pi. Now even function and odd function. Even function is if we replace x by minus x, then f of minus x is equal to f of x. So cos x, x square, x sin x, sec x, these are all even function. Why? Because if we replace x by minus x here, cos of minus x is always cos x, minus x square, that is x square, then minus x into sin of minus x is minus sin x. So minus into minus it become plus. So x into sin x is a even function. Sec of minus x is sec x, therefore sec x is also even function. And for even function, if we need to understand it by graphically, even function graph is always symmetrical about y-axis. Then odd function. Odd function is a function, if we replace x by minus x, then we are getting minus of f of x. Means same function with negative sign. So that is called as odd function. That is sine of minus x is minus sin x. Tan of minus x is minus tan x. X is replaced by minus x, so we will get minus of x. Then minus x into cos of minus x. But cos of minus x is cos x. So minus x multiplied by cos x is minus of x cos x. Similarly, cosec x is also an odd function. And odd function graph is always symmetrical about origin as well as in opposite coordinate. Now some terms are there, that is addition of even function, addition of odd function, multiplication of even function, multiplication of odd function. So even plus minus even is always even, odd plus minus odd is always odd, even multiplied by even is even, even divided by even is also even. So these are the some definitions of even and odd functions. Now if any function, if we want to express it into Fourier series, it must satisfy Dirichlet conditions. Now what are Dirichlet condition? If the function f of x is defined in some interval, that is c to c plus 12, where c is a constant term, it has any value, such that if f of x satisfies these conditions 1 to 4, then we can say that we can express this function f of x in terms of Fourier series. So what are the condition? First condition is f of x must be a single valued function. Single valued function means for one variable, one value of variable, we must get only one value of function. That is called as single valued function. Then integration in that interval c to c plus 12 must exist. Integration of f of x dx must exist. Next is f of x may have finite number of infinite or infinite number of discontinuities in the interval. So sometimes there is a discontinuities in the graph of periodic functions. So in that discontinuities may be finite or it may be infinite number of discontinuities. Next is f of x may have finite number of maxima or minima in the given interval. So we know that sin x graph, so it has maximum value is plus 1 and minimum value is minus 1 in a one particular time period, that is t. So it has a finite number of maxima as well as minima in a given interval. Next, some important formula we need to understand. First is this integration by part is very important formula for to solve Fourier series example. So you all know that integration of u into v dx is u into integration of v dx minus integration of derivative of first function, that is u, multiplied by integration of v dx multiplied by dx. Now one generalized rule of integration of part is there, which is derived by Leibniz. So it is also called as Leibniz rule. It is defined as integration of u into v dx. It is equal to first function as it is. See here, u we keep first as it is. Then we find out u dash, then u double dash, then u triple dash, and so on. And then v is a second function. First find out the integration of v. Then again integration of v1, which is v2, again integration of v2, which gives us v3, and so on. And write alternate positive and negative sign. First term is positive, second negative, then positive, then negative. So generalized rule is u into v1 minus u dash into v2 plus u double dash into v3, and so on. Then next important formula we need here, integration of e to the power ax into sin bx and integration of e to the power ax into cos bx. Formula for both the integrals are same, only there is a little bit change in the formula. First, it is e to the power ax by a square plus b square is common in both the formula. Since we are going to derive it for sin term will be first and next will be cos term. So it is a multiplied by sin bx minus b multiplied by cos bx. And in cos formula, first cos and then sin. A multiplied by cos bx plus here b multiplied by sin bx. So remember both the formulae. There is a similarity in the formula. Sin means first sin, next cos. Cos means first cos, next sin. First, if we have sin, in between sin and cos we have negative, and if we have cos, then in between sin and cos we have positive term. Then this angles formula, that is 2 sin a into cos b is sin of a plus b plus sin of a minus b. 2 cos a into sin b is sin of a plus b minus sin of a minus b. 2 cos a into cos b is cos of a plus b plus cos of a minus b. 2 sin a into sin b is cos of a minus b minus cos of a plus b. Next important formula for Fourier series is cos of n pi. Now cos of n pi has two values which depends on the value of n. So it is equal to, in general it is minus 1 to the power n formula, but it is divided into 2 pi. it is minus 1 if n is odd and it is plus 1 if n is even. That is, if you substitute here n is equal to 2, which is a even number, so minus 1 square is always even, that's why we are getting plus, and minus 1 to the power 1, which is always odd, which is equal to minus. Then sine of n pi. Sine of n pi, for n is equal to 1, sin pi we get, so sin pi is always 0. N is equal to 2, sin 2 pi is also 0, sin 3 pi is also 0. So in general, sin n pi values is equal to 0. Then cos of 2n pi, same formula, in place of n we have 2n. So it is minus 1 to the power 2n. Now if n is even or odd, for both numbers we will get here even number because it is 2 multiplied by n. So if n is equal to 1, we will get 2. If n is equal to 2, we will get 4. So all even numbers we are getting means value of the answer for that function is, it is equal to 1. Next, cos of 2n plus 1 into pi. So multiply this pi to inside this bracket. Inside the bracket, it become cos of 2n pi plus pi. So cos of pi plus theta is minus cos theta. So it become minus of cos of 2n pi, which is nothing but 1 with minus sign. So it is minus 1. Similarly, cos of n minus 1 into pi is cos of n plus 1 into pi. Minus 1 to the power n is equal to minus 1 to the power minus 1. So these are the some results. Sin cos n pi by 2, sin n pi by 2. Next important formula is minus a to a f of x dx. It is equal to 2 times 0 to a f of x dx. This is the integration property. If the function is even, we can write it as 2 times 0 to a, and if the function is odd, we can write it as 0. Next, definition of Fourier series. If f of x is a periodic function of period 2L defined in the interval c to c plus 2L and satisfies Dirichlet condition, then f of x can be expressed as, if this is a periodic function in any interval, then f of x can be written as a0 by 2 plus summation n is equal to 1 to infinity an cos n pi x by n plus bn sin n pi x by n. L may have any value. So we need to find out this a0, an and bn, which is called as Fourier coefficient. Fourier coefficient. So a0 value is 1 by L, 1 by L c to c plus 2L f of x dx. An value is 1 by L c to c plus 2L f of x multiplied by cosine function in an, and in a0 only it is integration of f of x. Bn is 1 by L c to c plus 2L f of x multiplied by sine function. So sin n pi x by L dx. If interval is minus, if the function is even, then only two coefficient we need to calculate, which is a0 is equal to 2 by L from 0 to L f of x dx, and an is 2 by L 0 to L f of x cos n pi x by L dx, and bn coefficient become 0 because in bn coefficient it is f of x multiplied by f of x multiplied by sin n pi x by n. So if f of x is even, even multiplied by sine function is odd. So even multiplied by odd, it is odd. That's why bn value become 0, and Fourier series get reduces to a0 by 2 plus summation n is equal to 1 to infinity an cos n pi x by n. There will be no bn term in this series. So and this series is also known as half range Fourier cosine series. Now what is odd function? Odd function we already studied. In odd function, a0 is 0, an coefficient is also 0. Only remaining is bn coefficient, which is 2 by L 0 to L f of x sin n pi x by L dx. Therefore, f of x reduces to n is equal to 1 to infinity bn sin n pi x by n, and this series is also known as half range sine series. Now if the function is neither even nor odd, we have to calculate complete term, that is complete 1 by L minus n to L f of x dx is a0. Then an is 1 by L minus n to L f of x cos n pi x by L dx, and bn is 1 by L minus n to L f of x sin n pi x by L dx. The even and odd function we need to check only when the interval is from minus n to L. Otherwise, if a function is neither even nor odd, calculate all the Fourier coefficient, that is a0, an and bn, and complete Fourier series we will get, that is a0 by 2 plus summation n is equal to 1 to infinity n cos n pi x by n plus bn sin n pi x by n. So this is all about introduction of Fourier series. In next video we will discuss about examples of Fourier series. Thank you.